Good morning, students. Today we'll start our 6.2 question number 1. In figure 6.21, Roman figure 1 and 2, DE is parallel to BC. Find EC in Roman figure 1 and AD in Roman figure 2. The figure that you see right now is your Roman figure 1, and we're going to start solving from here. First, let us write the given. In given, what shall we write? We'll just write here in triangle A, B, C. I can write here DE is parallel to BC. AD is 1.5 centimeter. DB is 3 centimeter. DB is 3 centimeter. And next we have an AE is 1 centimeter. I have completed writing the given. Next, let me write what we are supposed to find. We have to find EC. I will write here to find EC. Next procedure. What happened here? In this triangle, what happened? In triangle ABC, we know that DE parallel to BC. So what you can write here, you can write AD by DB equal to AE by EC. And beside this, let us give the reason. This is from Thales theorem. Okay, I'll drag the screen. Implies what is AD? AD is 1.5 centimeter. So let me write just 1.5. What about DB? DB is 3. What about AE? AE is 1, and then here EC. Okay, so 1.5 into 1, 1.5. 1.5 into 2, we have here 3. So now it's 1 by 2 equal to 1 by EC. So in the next step, what happened? I can write implies EC into 1 will have here EC. Then here this is 2 into 1, 2. So it's nothing but your centimeter. Therefore, you can just write here EC is how much? 2 centimeter. We have Roman figure 2. First, I'll write given. What is given here? In triangle ABC, DE is parallel to BC. This is the given. And moreover, I can write here DB is how much? DB is 7.2 centimeter. Next, I can write AE is 1.8 centimeter. And EC is how much? 5.4 centimeter. Next, I'll write to find. What I have to find? I have to find the length of this AD. So AD. Next procedure. Okay, so I can write here in triangle ABC, we have here DE parallel to BC. After writing this, I can write here AD by DB equal to AE by EC. So what is the reason behind here? The reason is you can write from Thales theorem. What is the line of AD? We do not know. So I'll just write AD. What about DB? The line of DB is 7.2. 7.2. And what about AE? This is 1.8. And what about EC? This is 5.4 AD. So I'll write here AD equal to, now 1.8 into 7.2 divided by 5.4. And we have seen here all these three numbers. are having point. So you can do like this. You can write 18 into 72. What I'm doing here, I simply multiply them by 10 into 10. 10 into 10 in the numerator. But in the denominator, what happened? I have to multiply by 10 and 10 again. Okay, so 10 has multiplied, then we multiplied, and this 10 I'm going to multiply to 5.4, so that you'll be getting 54, and this 10 you need to write here. 18 1 is 18, 18 3, 54. 3 and 72 we're going to cancel. 3 2 are 6, 3 4, 12. Now we have here how much? 24 by 10. 24 by 10 means you can write 2.4. So I'll just write here, you can write equal to 2.4 centimeter. So therefore AD is how much? 2.4 centimeter. We have question number 2. E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF is parallel to QR. Here the first question is PE is how much? 3.9. EQ is how much? 3 centimeter. PF is how much? 3.6 centimeter. And FR is 9 centimeter. Here in this question, what happened? The figure is not given to us directly. We have to draw by our own. Okay, E and F are points on the sides PQ and PR respectively of a triangle PQR. Okay, so first I'll draw a triangle here, and the name of the triangle is PQR. E and F are the points on PQ and PR. So this point is what? E. And this is what? F. Now E lies on PQ and F lies on FR. What is the length of this PE? PE is 3.9 centimeter. So I can just write here 3.9 centimeter. And what about EQ? EQ means 3 centimeter. What about PF? PF is 3.6 centimeter. And what about this FR? This is 9 centimeter. Sorry, this is 2.4 centimeter. This is 2.4 centimeter. So I'll write here 2.4 centimeter. So in this case, what happened? We're going to check whether this EF is parallel to QR or not. So it is all about the converse of the basic proportionality theorem. So let's start the solution. First I'll write given. In given, what happened? I'm going to write in triangle PQR. You can write E and F lie on PQ and PR respectively. And after what we can write, and this what happened? PE is 3.9 centimeter. Next, EQ is 3 centimeter. PF is 3.6 centimeter. And FR is how much? 2.4 centimeter. We have written the given. But what we have to do? We have to check whether this EF is parallel to QR or not. To check EF parallel QR. Next, I'll continue here. I'll write procedure. Okay, what happened now? First, let us find the value of PE by EQ. PE by EQ. What is PQ here? Sorry, what is PE here? 3.9 centimeter. What about EQ? This is 3 centimeter. We can cancel this centimeter. And what happened now? We have 3.9 divided by 3. So first let me remove this point. If you multiply both 3.9 and 3 by 10 each, then you'll be getting here how much? 39 by 3. So you can cancel now. 39 by 30. So 310, 30, 31, then 33. So what do you get now? You get 13 by 10. You can write here next PF by FR. PF by FR. What is PF here? PF means 3.6 centimeter. What about FR? 2.4 centimeter. Centimeter cancel, and what happened? If you multiply 3.6 and 2.4 by 10 each, I'm sure you'll be getting here 36 by 24. Now let us cancel it. 3, 8, 24. Then 3, 1 is 3, 3, 2. Still we can cancel. 4, 2 are 8, 4, 3, 12. So what happened now? You get here 3 by 2. Now 3 by 2 means we cannot cancel anymore. And what about 13 by 10? Even 13 by 10 we cannot cancel anymore. So what happened here? PE by EQ is 13 by 10 and PF by FR is 3 by 2. The ratios are not equal. So I will write here, that is PE by EQ is not equal to PF by FR. So what is the conclusion here? The ratios are not equal. That means EF is not parallel to QR. So we'll write like this here. From the converse of Thales theorem, EF is not parallel to QR. EF is not parallel to QR. We have row 1 figure 2. First we'll write given. In given, what shall we write? I'll write in triangle PQR. What we can write? We can write E and F lie on PQ and PR respectively. After that, what happened? We can write PE is how much? 4 centimeter. EQ is how much? 4.5 centimeter. Next, PF 8 centimeter. And at the last, I can write FR is how much? 9 centimeter. Next, I'll write here to check. What do we have to check? We have to check whether EF is parallel to QR or not. So I'll write here EF parallel QR. Next we have procedure. In procedure, what happened? I'm going to write like this. First I'll find here PE by EQ. PE means 4 centimeter. And what about EQ? 4.5 centimeter. Now there is a point in the denominator. Now there is a point in the denominator. It's a decimal number. So first let me cancel centimeter. In order to remove this point, we have to multiply by 10. So 4.5 into 10, we'll be getting 45. As I multiply 10 to 4.5, I need to multiply the same 10 to this even 4. So we'll be getting here 40. 5, 9, 45, 5, 8, 40. After this, we cannot cancel anymore. So I'm going to write here 8 by 9. Next, let us find the value of PF by FR. PF how much? 8 centimeter. And what about FR? This is 9 centimeter. Centimeter we cancel, so that I can just get here 8 by 9. 8 by 9 means we cannot cancel anymore. That is PE by EQ equal to PF by FR. Now the ratios are equal. Therefore, what happened? I can write EF is parallel to QR. From converse of Thales theorem, I can conclude that EF parallel what? QR. We have question number 3. In figure 6.22, if LM is parallel to CB. Okay, let's see. LM. Where is LM? This is LM. This LM is what happened? Parallel to CB here. So these two are parallel. And next, LN. This is your LN is parallel to CD. And again, these two are parallel. Okay. So what happened next? Prove that AM by AB equal to AN by what happened? AD. This is what we are going to prove. First, we'll write the given. I can write in triangle ABC. ABC. What happened? LM is parallel to CB. LM is parallel to CB. Next, I can write in triangle ADC. ADC. I can write NL. Sorry. Yeah, you can write NL or LN. That is up to you. But let me just follow exactly what is given in the question. LN is parallel to CD. And what we have to prove? We have to prove that AM by AB equal to AN by AD. I have written this one. We'll continue now. Here, procedure. Okay, first let us consider the triangle ABC. In triangle ABC, what happened? We have written even in the given as well. This LM is parallel to CB. So what happened? You can write AM by MB equal to AL by LC. Let me repeat. AM by MB. AM by MB equal to AL by LC. Okay, and you can write here from Thales theorem. Thales theorem. And this one I'll give equation 1. Next, we're going to write in triangle ADC. ADC. What happened? NL is parallel to DC. And for that, what happened? I can write AN by ND equal to AL by LC. Let me show you how I write here. AN by ND, then AL by LC. And this is equation 2. And here also you can write from Thales theorem. Now we have two equations. They are equation 1 and 2. Here in equation 1 we have AM by MB equal to AL by LC. In the second equation we have AN by ND equal to AL by LC. So from these two equations, what happened? Right sides are equal. Therefore, their left will be definitely equal. So I can write in the next step from 1 and 2. From equation 1 and 2, we get what happened? I can write AM by MB equal to AN by ND. Okay, let me do like this. This AM by MB, let me write its reciprocal like this: MB divided by AM. As I'm writing the reciprocal of the left hand side, even for the right hand side I need to write the reciprocal. So I'll be writing here ND by AN. And after that, what happened? On both the sides, let us add 1. Let us add 1 each on both the sides. MB by AM plus 1 equal to ND by AN plus 1. So after it, what happened? We'll take the LCM. If we happen to take the LCM, I'm sure we'll be getting here AM. Then here MB plus AM. Then here what happened? You'll get AN. Then in numerator you can write ND plus AN. Okay, let us look at the figure. If we add MB and AM, MB and AM, let us see. MB, this is your MB, and this is your AM. If I add MB and AM, I'm sure you'll be getting the whole AB. And what about this ND plus AN? This is your ND, this is your ND, and this is your AN. If you add ND and AN, what happened? You'll get the whole AD. So what we can write? We can write here AB by AM equal to, here I can write AD by AN. But what we have to prove now? We have to prove that AM by AB. I'll just write here AM by AB equal to AN by AD. This is what we are going to prove. Okay, let's see now. Now what happened on the left hand side? Let us write the reciprocal. So implies, I'll write here AM by AB equal to, as I write the reciprocal on the left hand side, even I need to write the reciprocal of the right hand side. I have written the reciprocal of left hand side. That means even for the right, I need to write the reciprocal. So AN divided by AD. So hence proof.